In this tutorial, we're going to show you how to use a digital pin on the Freedom KO25Z microcontroller as an output. This pretty much allows the microcontroller to turn one of its pins on and off, and it's one of the most fundamental operations of a microcontroller. Now, this microcontroller has many digital pins that you can use to do this. All of the digital pins on the KL25Z can be used to do this, but for the sake of our demonstration, we're going to connect an LED to the pin called PTD2, and we'll program the microcontroller to blink the LED on and off. Let's first wire this all up. We'll be using a breadboard just to simplify things. You can look online for the pin locations on the board, but if you flip the board over, there will be a silkscreen layer that shows you the pin locations. We'll need to find the pin PTD2 and the ground pin. Now, locate the ground pin and connect that to the ground line on the breadboard. Then connect PTD2 and connect that to the power line on the board. Then connect the cathode of the LED to ground and the anode onto the center of the board. Make sure that the direction is correct. Note that the shorter metal pin is the cathode, and that should connect to ground. Then use a resistor to connect the power line to the LED. The resistor we used in this case was 620 ohms, but anything less than 5 kilo ohms should be fine. You should now be set. Now Max will cover how to program the microcontroller.
Alright, so now we're going to start writing the code that's going to be running on the microcontroller to blink the LED on and off. To get started, we're from the mbed.org homepage. We're going to go to the mbed compiler, which is accessed by this button up here in the top right corner. So I'm going to go ahead and click that, which will take me to their online compiler interface here. So in order to compile our LED program, we're going to need to go over to the sidebar on the left here, the Program Workspaces bar, and we're going to right-click and create a new program, like so. Now, we don't want to use any of their template code, so we're just going to start off with an empty program, and you need to make sure that the platform that's selected is the right one for the microcontroller you're using. Right now, we're using the FRDM KL25Z, which is selected here, so everything's good there. We'll give it a nice descriptive name like LED_test and hit OK to have it create a new program for us. Now, in order to get started with this, we're going to need to import the mBed library. This is going to give us access to all of the default mBed functionality on the microcontroller itself, like controlling individual output pins or getting the system information. All of that stuff is in the mBed library. So to do that, we're going to right-click on our program, go to Import Library from Import Wizard. And that'll bring up a nice list here of all of the available libraries to import. The mBed library itself is the most important one. You're pretty much going to be using it in every project on here. So just select that row that says mBed under name and then hit the import button here and just use all the default parameters because they will work perfectly fine. And so this will bring the mBed library and all of its compiled binaries and everything and its headers into our current program here. So you see the little gear icon there with mBed next to it. And here you have access to the documentation for all of the classes and etc. that are used inside of the mBed library. So now we need to actually write our program. So we're going to start off by creating a new file, and just by the standard paradigm, we're going to name the main starting file for our program main.cpp. And hit OK. So now we've created our new program here. I don't like using the editor that's on here on their online compiler interface for mBed. I prefer to just write the code on my own local machine and then just copy and paste it here when I need to do the compilation. So I'm going to switch over to my text editor here, which is Sublime Text. And so we're going to start writing the code for this simple our Hello World microcontroller program. So the first thing that we need to do is we need to add the mBed library header to our file so that we have access to everything that's in the mBed library. So we're going to do that with a simple include statement, and we're going to include mbed.h. You're probably going to just want to have this included in every one of your program files because it's essential to doing everything with the mBed microcontrollers. The next thing that we're going to do is we're going to want to declare and define a DigitalOut object, which is of type DigitalOut. And what this is a class that has been defined by mBed that lets you really easily control the pins on the mBed board that are the digital output pins. So for example, you can drive them high or low, or you can read them whether or not they are high or low. So this will just give you a way of interfacing with other digital things. So because we are just going to be turning this LED on or off using the digital output pins, this is all we need to use. And so we're just going to call this LED pin for convenience. Now, when you define one of these digital out objects, you need to tell mBed which pin you want to use in order for this particular instance. So for here, mBed has defined a bunch of constants, which are the names of all of the pins on the board. So we are going to have it go over the PTD2 digital output pin on the actual mBed board itself. So this is a constant which is defined inside mBed.h, which will let it recognize that we want to, using LED pin, this C++ object, we want to control the PTD2 pin on the board itself. So now we're going to create the int main, the main entry point for our program. And the first thing that we're going to do, just as a simple starting point, is we're just going to turn this pin on. And this object has a really easy syntax for doing that. It is just LED pin equals 1. So if you want to turn it on, you set it equal to 1. And if you want to turn it off, you set it equal to 0. But for right now, we'll just leave it on. Now we want to have the pin blink over and over again. And so we're just going to make a while loop, like so. This while loop will keep looping the code inside of here forever because it's going to be looping while the condition inside the parentheses is true. Since the conditions inside the parentheses are true by definition, it will just go on and on forever until the device breaks or the end of the world comes. So we want to, inside of here, have it blink off and on again. So we'll do that just using the syntax that I showed you up above. So we have LED pin equals 0 and then LED pin equals 1. Right? That will have it turn the pin off and then turn the pin on, and then it'll loop back around and turn the pin off and on and off and on and off and on again. But the problem with this is that it's going to be really, really fast at blinking this LED because the microcontroller executes this code extremely quickly. So you actually probably won't be able to see the LED flash on and on because it would be going so fast. So we need to have the microcontroller wait a little bit in order to have it blink at a reasonable speed. There is thankfully a built-in function called wait, which takes as its argument the number of seconds that you want to wait. So in this case, we will wait half a second in between the turning off and turning on of the LED. So here in this loop, we'll have it wait half a second, turn the LED off, then wait half a second, then turn the LED on again. And that's really all there is to it. This program is perfectly fine and it will run. So now that we have this program written and we want to compile it, I will go ahead and select all and then go copy and go back over to the compiler interface and just paste this in. Give it a second. Okay, there we go. So we got the program in here to the compiler interface. Now what we're going to do is we are going to just hit the compile button. It'll automatically save the code that we have here and then compile it for our platform. And then it sends the binary that it has compiled into the downloads folder on your local machine. So if you want to see that, you can just pull up your hard drive and then go to your downloads. And we see here that we've got this .bin file, which contains the binaries for our program. So if we drag this onto the mBed controller when we have it attached, that will upload the program onto it and we'll see what happens. So here now I'm going to attach the microcontroller to the computer, and what you should see is that as soon as I plug this bad boy in, like so, it actually mounts it as a USB storage device here. So there it is, the mBed drive. So if I want to upload this onto the microcontroller, all I have to do is drag the binary file onto the mBed disk there, and it will automatically upload, which you will see as a fast blinking LED on the controller. And then you just have to hit the reset button and it will start running the program.